And here we go. Today we're going to be looking at lesson 4.3 and its title, Rate of Change and Slope. So we're going to look at the differences and the similarities between those two phrases. Today's objectives: finding rates of change and slopes, and relating a constant rate of change to the slope of a line. Recall that in prior lessons we talked about the slope of a line being the same as a constant rate of change. So please go ahead and write down these vocabulary words, and we'll work on some working definitions as we go through the material. A rate of change is the ratio that compares the amount of change in the dependent variable to the amount in the independent. Notice the order in which we said them. It's dependent to independent. Therefore, dependent is the numerator, independent is our denominator, and recall that dependent is our change in the y variable, while change in the independent variable is the x. So we refer to a rate of change as the change in the dependent, or the y, over the change in the independent, which is the x. Let's go ahead and apply what we know already. Example 1, it says the table shows the average temperature in Fahrenheit for 5 months in a certain city. Find the rate of change for each time period. During which time period did the temperature increase at the fastest rate? So, first thing we have to do is determine which one of these is independent. Well, the months tend to move along no matter what. And depending on which month we're in, the temperature usually is about the same each year. So the temperature depends on the month. Dependent is temperature, independent is month. So we're going to find the rates of change. From 2 to 3, the change in the temperature was 56 degrees to 56. It changed 0, and the change in months is 1. What we're going to do with each of these is make them over 1 month. So it's 0 over 1. The next one, 63 to 56, we see a decrease of 7 degrees over 2 months. So we do that division. That's 3.5 degrees per month. 5th to 7th month, we see a 4-degree change. Again, just taking the differences in the dependent over the independent. And finally, a change of 1 degree per month. Now, I wanted to know which one had the most drastic change. And we could see that right there. From the 5th to 7th month, 4 degrees per month was the biggest change. Let's go ahead and let you guys check it out. Example 1, table shows the balance of a bank account. Find each rate of change and the interval in which the balance decreases at the greatest rate. Go ahead and calculate those rates of change and come right back here and we'll check your answers. So step number 1 is to identify dependent and independent. And we've talked about time. Time basically is always independent. So we're going to look for the change in the balance over the change in the days. Dependent is balance, independent is days. Finding each rate of change from 1 to 6. The change in the balance, it went down 265 over 5 days. We're going to divide numerator by denominator for an average change of $53 per day. That's spending. That's because of the negative. Changing in balance from 6 to 16, we see we went down $75 over 10 days. That's $750 a day. Average spending. Another $0 per day. And finally, negative $4.38 if we round up per day. And we can see our greatest rate of change is from day 1 to 6, where we have an average spending of $53 per day. Example 2, let's find the rates of change from the graph. Now you've noticed from the tables that we don't have constant rates of change. That's typically when we find rates of change independently. So let's look at this first segment right here at the bottom. From month 2 to 3, we see a change of 0 in average temperature. The months went from February to March, but the average temperatures did not change. Then we went from March to the 5th month, May. We go from month 3 to 5, we see a rise of 7 degrees over 2 months. In the next section, we see a rise of 8 degrees over 2 months, and then a rise of 1 per 1 month. And that rise is an average temperature for the month. So we can compare the greatest rates of change represented by the steepest red line. We can see this section, 8 degrees over 2 months, would average to 4 degrees per month. Here we would have 3.5 degrees. So we can see our greatest rate of change between month 5 and month 7. Let's look at example 2 and graph the data from the check it out example number 1. The vertical segments shown are changes in the independent variable, and the horizontal segments show the changes in the independent. So vertical is dependent, horizontal is independent, and we can talk about these rates of change. This is negative 265 over 5. And we know that's going to give us a negative rate of change of 23 degrees, negative 23 degrees. And sure enough, we look at our line, and it has a negative slope. We can see all of these segments, except for this one right here, having a negative slope. The greatest rate of change is represented by the steepest. This would be the steepest, and we could see that it is negative 53 degrees per day. If all the connected segments have the same rate of change, then they all have the same steepness and together form a straight line. The constant rate of change of a line is called the slope. So now we're getting into slope, we're getting into linear functions, and we know one thing to be true: the slope along each segment is always going to be the same. We're going to talk about the rise, the difference in the y values, over the run, which is the difference in the x values. You can see our definition of slope right here: rise over run, or the change in y over the change in x. Remember, y is dependent and x is always independent. Let's find the slope of this line. Begin at one point and count vertically to find the rise. Well, here's a point on the line. Let's see what they choose. They're choosing this point. So vertically, we're going to travel up from the point 3,2 to the same level that our other point is on. So we went up 1, 2, 3 units, and we went over -9. And again, we can see the slope has a negative slope. So now we're going to take the change in the rise over the change in the run. Change in the rise, in this case, -3. Change in the run is +9. We can see the same thing's going to happen over here. The change in the rise is positive over the run, which is negative. In each case, we end up with a slope of -1/3. Go ahead and find the slope of this line. Now we're given 2 points. We can use the graph by simply counting the rise over run. So just like we did in the last example, it says we're going to start at one point. It doesn't really matter which one. They start at the lower point, 5, -5. And we're going to calculate the rise to the level of the next point. We can see that rise is +2. From -5 to -3, we've gone up 2. And we're going to count the amount of run over to the point. So from point to point on the line, we have a rise of 2 and a run, because we're going backwards, of -5. We're going in the negative x direction. So we have to make sure and indicate that that run is negative. We're going to simplify our slope, -2 over 5. And it doesn't matter which way we start. We can also talk about a rise of -2 over a positive run, giving us the same slope, -2/5. Example 4, we have 2 special cases in which we refer to the slopes of lines as way too steep to talk about. We're going to call this undefined. If you think about this line right here, we have rise from -2 to +4. we have a rise of 6, but our run is 0. And remember, we can't divide by 0. Calculator says error. It's an undefined number, and we refer to this slope as being undefined. Here's our other special line. We rise 0 from one point to the other. We didn't go up or down, but we did run. We rose 0 and ran 12. 0 over 12 is 0. Find the slope of each one of these lines. This is check it out example 4. We can see rise of -8 over 0. Cannot divide by 0, therefore this slope is undefined, and this slope is 0. As shown in the previous examples, these are good notes. These are found on page 246. We need to remember that slopes rising from left to right are positive slopes. Falling from left to right, they have a negative slope. Horizontal or flat is a 0 slope, and vertical, straight up and down, top to bottom, is an undefined slope. Let's tell whether each one of these is positive, negative, or 0. Well, I don't see a horizontal line and I don't see a vertical, so we know we have either positive or negative. Looking at this one from left to right, I see that we're moving upward. We would define that as a positive slope. This one going from left to right, the line is going downward. It falls, therefore the slope is negative. I see one of our special cases here. We have rise. Let's say we have a rise of 4. Run is 0. 4 divided by 0 is undefined. Rising from left to right is positive. On page 247, we want to be able to compare slopes, and that says to me which one's steeper. Positive and negative do not matter at this point. We're going to take the absolute value of each one of those slopes and compare. We see the blue line being very steep, the red being less steep. We're going to take that rise of 1 over 2 and this rise of up 4 over 1. Comparing the two, we see that the slope, or the blue line, has a steeper slope. In the middle section, I'm going to be comparing a -1 slope to a -2 slope. Again, comparing the absolute values, absolute value of -2 is greater than -1. Therefore, the blue line, -2 slope, is steeper than the red, or a -1 slope. Comparing red and blue in the far right picture, we have a slope of 3/4 and a slope of -3. And we compare again, -3 is bigger than 3/4. Please look on PowerSchool and get your assignment for lesson 4.3.